Okay guys, so today what we're going to do is talk about functions. We're going to be translating functions, okay? But we're going to do more transformations. So when you do a transformation, you're really going to change the shape of it, okay? So transformation is to change the shape, okay? A translation is just going to be to move it. Position. Good, yeah. But a transformation is going to change shape. It's going to either make it wider, skinnier, or whatever, right? Or, if you flip it, it's still translation, okay? All right, so let's take a look. So given f of x equals square root of x, so we know that the parent function looks like that. Agree? Absolute value is the v, okay? And then if we want to sketch this transformation, we're going to take f of x. We're going to take this function, and it's worded a little bit differently, isn't it? So the only thing is it tells you take your function and move it back 3, down 2. So it's just the wording of it. So f of x is our function. We're going to take our function and move it back 3 because of the opposite, right? Opposite the inside. So we take the same function, we move it back 3, down 2. So it's a lot like what we did yesterday. The only difference is how we word the problem. Okay? Okay, so far so good. Now, let's talk about domain. I haven't talked about domain and range, have I yet? Let's talk about... We did? We talked a little bit about domain? Okay. Okay, what's the domain of this function? Good. All real numbers. And the range. What's the range? You're so awesome. Thank you. Everybody agree? Saul? You okay with that? Okay. Okay. Let's graph fx equals x. Okay. Up 1 over 1, up 1 over 1. It's a straight line. Okay. And again, it's the wording. The wording has to do with take it back or go to the left. Actually, I said it wrong. Go to the right 1 and up 5 because it's going to be the opposite, right? So we're going to go and do the opposite. So the opposite is going to be to take a graph. So the whole entire graph is going to go 1 and then 1, 2, 3, 4, 5. And there it is. If we need a new equation, the new equation would be simply, let's call it g of x because it's our new equation. I'd go g of x equals, in this case, it's going to be a x plus 5, right? Domain, what do you think? Domain, x equals all real numbers, thanks Daisy, and range, it is all real numbers. Now, don't let me freak out, but I'm going to write it like this because you're going to see this in pre-calc and calc. F of x equals all real numbers. Because in our case, f of x and y are the same thing, aren't they? F of x and y are the same thing. Does that bother you a little bit? F of x instead of y? Okay. As long as you know that in our case, until we do circles, f of x and y are the same thing. Okay? All right, now, x squared. So the parent function looks like this. 1, 1, 2, 1, 2, 3, 4. All right. So here's my parent function. And we're going to take this particular function. We're going to take it up 4. And then we're going to make it negative 2 times as tall. How's that work? Well, let's take it up 4. 1, 2, 3, 4. Okay, so bring it to 4. And then we're going to make it upside down, right? And then we're going to make it twice as tall. Okay, so I like to do the x squared in my head. 1 squared is 1. 2 squared is 4. 3 squared is 9, right? So I'm going to go, okay, 1 squared is 1, but twice as tall. tall. I'm going to go to 2. 1, 2. 2 squared is 4. 1, 2, 3, 4, but twice as tall. 4, 5, 6, 7, 8. 3 squared. 1, 2, 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But twice as tall, which is going to be off my graph, right? It's going to be like way down there. I'll just make an imaginary dot way down there, okay? And of course, we know parabolas are symmetrical, so I'm just going to go ahead and put another point here, here, and like pretend that's way down there, okay? And then I'm just going to draw in my function.
So that side of there, you just multiply it?
Yeah, you just multiply the height, double the height, right? And in this case, when I say height, you've got to be careful because we're going down, right? Yeah, so it's a stretch. So we're stretching the y values by 2. Okay, domain. What's the domain, you guys? X equals all real numbers. And what's our range? F of x is, what's our range? Nope, because there's nothing up here. There's nothing up here. There's nothing up, it doesn't, this graph doesn't exist up here. Less than or equal to, what's the highest height? 4, there you go. How's that? Starts at a height of 4 and goes down. There's no points, there's no values above that, so it just starts at 4 and goes down. The graph does. Yeah, Cole?
When you say all real numbers, what makes a number real?
Great. Okay, so here's one definition. If it's on the number line, it's a real number, like pi, right? Okay, numbers that are not real, yes, imaginary, okay? Those are not real numbers, okay? Does that make sense? Square root of 2. So any number that's on a number line is a real number, okay? Square root of 2, pi, e, which we haven't learned about e yet, but I'm going to give you the number e later. The number e? It's like, what? That was in math class. It just gets more fun all the time, doesn't it? Okay, turn the page. All right, now, square root of x looks like this. 1, 1, 1, 2, 3, 4, 2. See what I'm doing? I'm going 1. The square root of 1 is 1. I'm going over to 4. The square root of 4 is 2. I'm going to go over to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 3. Now, there's a whole lot of numbers in between I didn't say, but those are decimal answers. Okay, I didn't say 2 because the square root of 2 is 1.41. I didn't say 3 because the square root of 3 is about 1.73. I just want the shape, right? So I went over 1, I went over 2, and I went over 8 because those have square roots. Okay. Cole, this one's going to help answer your question. There's no numbers over here. You know why? Those would be square roots and negatives, which makes those numbers I, right? Does that make sense? Yeah, so all real numbers wouldn't work in this case, would it? So let's first of all, negative x squared is just going to take my graph and do what to it? Now if it's on the inside, think about this. X's become negative. X's become negative. So if these x's become negative, what happens to the graph? Over the y, doesn't it? So this 1 becomes negative 1. This 4 becomes a negative 4, right? This 9 becomes a negative 9. So if it's on the inside, it's a reflection over the y-axis. Okay, so my graph is going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my graph's going to go like that. Okay? There you go. Okay, so if it's f of negative x, my x's become negative. If my x's become negative, then they have to go to the other side, the negative side of the x-axis, which is a reflection over the y-axis. Okay, thumbs up. Okay, now let's take a look at domain. Okay, Cole, here we go. It's not all real numbers, is it? In fact, the x values go back. It equals 0, but then it goes back, right? So how about x is less than or equal to 0 for this graph, correct? How about range? It is greater than or equal to 0. Yeah, in fact, it equals 0. So I'm going to go f of x or y, same thing, is greater than or equal to 0. Yeah, starts at a height of 0 and goes up. You guys see that? I'm not confusing anybody? Real quick, check. Sideways, thumbs up. Sideways, 2 thumbs up. I like even 2 thumbs up is even better. Okay. All right. Okay.
I have a question.
Yes.
How do you come up with x is smaller or equal to 0?
Great question. Okay. So right here, the graph goes this way. Okay. So I'm starting here, and then I'm going back. Right.
What about the other side?
Well, that would be greater than or equal to, right? Yeah. Yeah. So this one's just going to be. This is a different graph. Okay. This is f of x. This one's x is greater than or equal to 0. And this graph is x is less than or equal to 0, okay? Because this graph goes from 0 back, and the other graph goes from 0 forward, okay? Yeah, Daisy.
Is there any where it's just less than 0?
Yes.
Like what is an open dot?
Yes. Yep. Yep. You are way ahead of me, and that's awesome. And yes, we're going to hit that one, but not today. Totally correct. Yep. In fact, there's going to be times where you're going to have to divide by 0 and you can't, but we're not there yet, and we're going to talk about that. Okay, great question. Okay, so x cubed looks like this. You ready? Start at 0 because 0 cubed is 0, right? 0 cubed is 0. 1 cubed, what's 1 times 1 times 1? 1. 2 cubed, what's 2 times 2 times 2? 1, 2, 3, 4, 5, 6, 7, 8. Awesome. And then off the graph, right? Negative 1 cubed. What's negative 1 times negative 1 times negative 1? Good. Thank you. Negative 1. I agree. Negative 2. It's negative 2 times negative 2 times negative 2. Negative 8. 1, 2, 3, 5, 6, 7, 8. And then off the graph. So let's go ahead and do this one here, okay? It's got a little bend, okay? So this little spot here where it changes is called an inflection point. And you're going to learn that in calculus. In here, we're just going to talk about it. We're not going to do much with an inflection point. In calculus, we will do a lot about an inflection point. This is a really important point in business. So in business, think about this. They talk about inflection points they really do. If you listen to the news, every now and then they'll talk about an inflection point. It's kind of crazy. So whatever. You know what an inflection point is. In business, check it out. Business is slowing down. And then what happens? Maybe they make their stock public. Maybe they open a new restaurant. An inflection point is a change in business. Sometimes it could even look like this in business, right? You could have an inflection point right there where business is looking good, and then all of a sudden you start to take a dive, right? And it could be because maybe you start to build a new restaurant, right? So you have all that cost, all that money, and then all of a sudden, once that restaurant is up and running, you start to make money again, right? That's an important point in business. Yes, Daisy and then Cole.
I've noticed, like, anytime you do to the power of, if it's like non-positive or odd number, it has an inflection point. But if it's even number,
We're going to look at those kind of graphs in about a week. Nice. Hang on to that. We're going to look at those graphs. Cole?
So is the inflection point kind of like the midway point of a change?
It is a change. In fact, if you think about slope, okay? Slope of a graph, the slope is becoming less and less and less, and then the slope starts to increase. Yes, it is a change. So it's a change in slope. Slope goes from possibly almost negative. In fact, in this case, the slope becomes negative. Then the slope all of a sudden changes to positive, okay? Yeah. It's the rate of change. Okay, good question. You guys are going to learn that in calculus when that day comes, okay? All right, cube root. So, oh, no, I'm not done with this one. Sorry. So when I move this one, let's move the inflection point. Does that make sense? We're going to move the inflection point. We're going to move it to the right, 3, and then up 2. So we're going to go 1, 2, 3, 1, 2. Okay, there it is right there. So it looks something like that. So the easiest way to move this one is, it doesn't have a vertex, but it has an inflection point. Okay, so if you move the inflection point, it's easier to move it. So this point moved to there. Domain. How wide is this graph? Domain is what? All real numbers. Range. Should be easy. Range. How tall is it? All real numbers. Yeah. F of x equals all real numbers. Okay, good. Almost done. Okay, we'll look at our journals. Okay. Cube root of x. So I'm going to do this. I'm going to start at 0. Cube root of 0 is 0. If I go over 1, the cube root of 1 is 1. Now I'm going to go all the way to 8. 1, 2, 3, 4, 5, 6, 7, 8, because the cube root of 8 is 2. And then there's a whole lot of numbers in between, but those are all decimal numbers, right? I mean, I could do the cube root of 2, and I could do the cube root of 3, but they're just ugly decimals, so I just want the general shape. Negative 1, what's the cube root of negative 1?
-1.
Totally right, yep. And then I'm going to go all the way to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. The cube root of negative 8 is negative 2, right? Okay, there it is. And it's just almost looks like our cube graph, except for it's on its side. It's its inverse. We'll talk about that again another day, okay? Now, we're going to move it back 2 and down 5, right? So I'm going to go back 2, down 1, 2, 3, 4, 5. I'm off my graph. That's, I guess, the way it goes. And I'm going to sketch it in lightly. It's going to look something like that, all right? Domain. Yeah, look how wide it is. Every single number's there, right? X equals all real numbers, and then range. It is. It kind of looks like it's flat out, but it's always going up, isn't it? Even though it's going to be going up very slowly, this graph is always moving up, and this graph is always moving down, even though it happens very gradually. So range is f of x equals all real numbers also. Okay, now let's take a look at what's in our journal, okay?